Hello dear students, good morning. Today we will see about the rocks and minerals which are found in India. First we discuss about rocks. Now what is rocks? It is a composite matter. It is a composite matter which is made of one or two minerals is called a rock. And rocks can be hard or soft. It is porous or non-porous. Now what is the meaning of porous? The meaning of porous means in some rocks there are some cells or intense intercellular from which air or any liquid can be passed, or it is called porous. So some rocks can be porous or non-porous. Some rocks can be light or heavy. So if we talk about rocks which are found in the world, so in the world many types of rocks are found, and many types of rocks are formed due to the different natural processes. Rocks can be divided into three categories. Here are the categories. First is igneous rocks, second is stratified rocks, and third is metamorphic rocks. Now what is igneous rocks? Igneous rocks is formed due to magma or lava. Stratified rock is also known as sedimentary rock, which is formed due to the deposition of sediments. And third one is metamorphic rock. Now what is metamorphic rock? So this rock is formed due to the heat, pressure under the surface of the earth. So these are the three types of rocks. To make you understand more in detail, I will show you some videos how the igneous, stratified or sedimentary and metamorphic rocks are formed. If we talk about igneous rocks in India, it founds in Rajasthan, Madhya Pradesh and southern peninsula. If we talk about stratified rocks or sedimentary rocks, it found or in Bihar and Jharkhand states in India. If we talk about metamorphic rocks, it is found in Rajasthan, and marble and quartzite which are available in Rajasthan. If we talk about, now we will discuss about mineral. So what is mineral? So mineral is a matter which is formed due to the natural, organic or inorganic process and has a special chemical composition is called mineral. Mineral can be solid, liquid or in gaseous form. So many minerals are found in India or in the different states or different parts of India. Minerals are classified in three categories: metallic, non-metallic and third is energy resources. In metallic, many precious metallic minerals are there, that is gold, silver, platinum, etc. Light metallic minerals are magnesium, bauxite, titanium. Minerals of general use is iron, copper, lead, zinc, tin, nickel, etc. And mineral used alloys are chromium, manganese, tungsten and vanadium, etc. are there. In non-metallic, limestone, chalk, asbestos, mica, fluorspar, gypsum, sulfur, diamond, etc. are found. And some minerals which are based on energy or which gives us energy are coal, mineral oil, natural gas, uranium, thorium, etc. So, we will understand, or I will make you understand through some videos, that how the rocks are formed, which minerals are found in which states of India, and in the states in which districts of that states. So, here are the videos related to the rocks and minerals. Watch it carefully and understand.
Igneous rocks. Objective: to learn about igneous rocks, their types, and formation. The Earth's crust is made up of different types of rocks. The rocks which make up the maximum volume of the Earth's crust are called igneous rocks. The word igneous has been derived from the Latin word ignis, which means fire. These rocks are associated with volcanic eruptions. Let's study more about igneous rocks and how they are formed. The liquid rock matter that we see coming out from volcanoes is called magma. It is a hot liquid made of melted minerals. When this magma reaches the Earth's surface, it is known as lava. The cooling and the solidification of lava at the Earth's surface result in the formation of extrusive igneous rocks, which are also known as volcanic rocks. Due to rapid cooling, their crystals are fine-grained. However, some of the magma can't come out and settles inside the surface. The magma cools slowly beneath the Earth's surface, as it is completely surrounded by the soil and rock present there. The cooling and the solidification of magma at a depth within the Earth's crust result in the formation of rocks having large crystals, known as intrusive igneous rocks. So we have learned that igneous rocks are of two types: extrusive igneous rocks and intrusive igneous rocks. It is interesting to know that igneous rocks were the first to be formed and are also known as primary rocks. Pumice and obsidian are extrusive igneous rocks. Pumice is used in making lightweight concrete, and obsidian is used in ornaments. Granite and diorite are intrusive igneous rocks. Both are used as building material. To summarize, igneous rocks are of two types: extrusive igneous rocks and intrusive igneous rocks. The cooling and the solidification of lava at the Earth's surface result in the formation of extrusive igneous rocks. They are also known as volcanic rocks. The cooling and the solidification of magma at a depth within the Earth's crust result in the formation of intrusive igneous rocks.
Sedimentary rocks form in a variety of environments on the Earth's surface. Geologists study modern environments to understand how rocks form today, and they use these data to better interpret ancient environments as preserved in the rock record. read these rocks to decipher past climates, reconstruct former landscapes, and predict where to search for oil and gas resources.
This lesson has two learning objectives. We will describe the three major classes of sedimentary rocks, discuss their formation, and explain where they are forming today on or near the Earth's surface.
There are three classes of sedimentary rocks: clastic, chemical, and biochemical sedimentary rocks. We can differentiate them on the basis of the materials that compose the rock and the processes by which they form. Let's look at the first category, the clastic sedimentary rocks.
There are three steps in the formation of clastic sedimentary rocks. Clastic sediments are composed of fragments of rock. In fact, a clast is a technical word geologists use to describe a rock fragment. These fragments weathered from pre-existing rocks to form sediment of various sizes. This sediment is then transported away from its source area, and finally it is deposited and converted to form a new rock through lithification.
Rocks break down on Earth's surface to form sediment. This sediment may be composed of the rock's constituent minerals, which may then be physically or chemically broken up further to form even smaller grains or other minerals. We can see the individual feldspar minerals weathering out of this igneous rock, and notice the grains of sediment at the base of the outcrop. Now we need to erode it or transport it away from its source.
Sediment is eroded by transportation agents such as streams. For example, this river in Alaska is carrying a high sediment load, as reflected by the muddy color of the water and the sand and gravel bars within the stream channel.
Sediment is also eroded by winds. Much of the topsoil of western Oklahoma and northern Texas was blown away during the Dust Bowl era in the 1930s. And we see similar dust storms known as haboobs today in drought-stricken western states. Elsewhere, dust and sediment from the Saharan Desert may be transported across the Atlantic Ocean to Central and North America.
Finally, sediment of all sizes can be transported by glaciers. For example, the dark surface on the Reed Glacier in Alaska reflects the sediment that is exposed as the ice melts. If we look closely at the glacier, we can see layers of sediment encased in the ice.
So sediment is first weathered from rocks during the breakdown phase, next it's eroded and transported, and finally it's dumped or deposited in some location. Sediment is deposited when rivers enter the ocean, or when wind velocity decreases, or where glaciers melt. As more and more sediment builds up, the material at the base of the pile is compacted. Compaction squeezes out spaces between grains and pushes the grains closer together. Finally, chemicals precipitate out of water to cement the grains together and form a rock.
Each size of clastic sediment produces a different type of clastic sedimentary rock. Sometimes the link between sediment and rock are obvious, such as the lithification of sand to form sandstone. Other times, the names of the sediment and the resulting sedimentary rock are quite different. For example, conglomerate forms from rounded gravels, and clay-sized particles are consolidated to form shale.
The second major category of sedimentary rocks are the chemical sedimentary rocks. Imagine that you left a pan of salted water on the stove for long enough. The water would evaporate away, leaving the salt behind. Essentially, the same thing happens in nature as water evaporates, leaving any dissolved minerals behind. For example, ancient Lake Bonneville covered much of Utah 10,000 years ago. Most of the lake dried up, leaving the flat lake bed covered in a layer of salt.
Most chemical sedimentary rocks form as a result of precipitation from seawater, but minerals are also dissolved in lesser concentrations in groundwater and freshwater lakes and rivers, and are also concentrated in hot waters associated with thermal features such as hot springs and geysers. Travertine, a type of limestone, forms when minerals precipitate in places where warm, chemical-rich waters come to the surface.
Biochemical sedimentary rocks also result from precipitation, but this precipitation occurs due to the actions of organisms, typically marine organisms. Think shellfish, for example. They form their shells by causing minerals to precipitate out of seawater. The same process can happen for microscopic marine organisms, like coccolithophores. Coccolithophores are composed of tiny plates known as coccoliths. Even though you couldn't see one of these with your naked eye, if you get enough of them together, you can create spectacular chalk cliffs, such as those along the southeast coast of England.
Other marine organisms, such as corals, clams, and oysters, also build shells that eventually form biochemical sedimentary rocks. Plants can also end up as rocks. For example, vegetation in tropical swamps can be compacted and compressed to form coal.
Finally, we can summarize what we have learned today to recognize that different types of sedimentary rocks leave clues to the past environments on Earth. Clastic sedimentary rocks such as conglomerate, shale, and sandstone can form in environments such as mountain streams, swamps, deltas, deserts, and beaches.
Chemical sedimentary rocks are formed in environments such as lagoons and groundwater systems. Biochemical sedimentary rocks such as limestone or chalk form in marine environments, while coal indicates the former presence of tropical wetland conditions.
Alright, in this video we're going to be talking about metamorphic rocks. Please get your rocks flowcharts ready so we can fill in our final third column. Now, recall, rocks are classified according to how they form. Igneous form from cooling and solidified magma. Sedimentary form from compacted and cemented sediments. And now our metamorphic rocks, these are ones that are going to undergo some sort of change, a metamorphosis. And what drives that change is exposure to heat, really intense heat, or pressure, intense pressure. So metamorphic rocks are rocks that are changed as a result of exposure to intense heat and or pressure. So there are two types of metamorphism that occur in nature. The first type is called contact metamorphism, and the second is called regional metamorphism. So let's talk a little bit about the difference between these two. Now, imagine you have the surface of the earth here, and you can see some trees, and these colors here, these are layers of rock underground. And so I'm going to show you how contact metamorphism works. The reason it's called contact is because it involves existing rocks coming into contact with really intense heat, which is generally provided by lava or magma. So imagine that one day an intrusion of magma forces its way up through these layers of rock. Now, all of the existing rock are going to be burned by the heat of the magma. So all along the edge of this magma, shown here in orange, you're going to have rocks that have been burned by the heat of the magma. That burning causes them to change or metamorphosize into something new. So anywhere you see the orange, you're going to have some metamorphic rock. This is caused primarily by heat. Let's fill this in on our flowchart. Okay, so the first type is contact metamorphism, and this is caused by contact with heat. Whenever a rock comes into contact with magma or lava, it is burned or metamorphosized by that heat. But let's talk about the second type, regional metamorphism. Now this one is going to be more from pressure. So let's imagine that I have a plate boundary here, a fault, a crack, and that these two plates are coming together. So it's a convergent plate boundary. Well, as you can imagine, in the middle here, there's going to be immense pressure. And that pressure can cause the rocks trapped in the middle to become metamorphosized. So all along this boundary, you'll find metamorphic rocks. Again, this is different from contact in that it's not so much about the heat, it's more about the pressure. Let's take a look at what we see here. This is a typical progression of metamorphism that occurs, starting with the sedimentary rock shale. If you add heat and pressure, it will metamorphosize to slate. If you add more heat and pressure, it will become phyllite, more, and it will become schist, even more, and it will become the metamorphic rock gneiss. Take a look at that gneiss sample down there. You'll notice it has bands of minerals. That's a result of the intense pressure. Now, if you were to take gneiss and add additional heat and pressure, it would likely melt into magma or lava, and then it would become an igneous rock. So gneiss is generally the extent of metamorphism that we see. Let's go back to our flowchart. So our second type of metamorphism is called regional metamorphism, and this is caused primarily by pressure. Of course, all of this is summarized in your reference tables on the metamorphic rock chart on page 6.
What are minerals? Geologists define minerals as a homogeneous, naturally occurring substance with a definable internal structure. For general and commercial purpose, minerals can be classified as metallic and non-metallic minerals. Again, when it comes to metallic minerals, it has two divisions, that is ferrous based and non-ferrous based. Among the ferrous base, the most important minerals that are used is iron ore, manganese ore and nickel. And the non-ferrous based are bauxite, copper, lead. Similarly, when it comes to non-metallic minerals, among the non-metallic minerals, the first one in India is mica, limestone, granite, marble, etc. Then there is one more category of minerals known as energy minerals, and this will have coal, mineral oil, natural gas. So, where are these minerals found? Minerals are usually found in the ores. The term ore is used to describe an accumulation of any mineral mixed with other elements. So let us begin with the first mineral, and that is iron ore. India is fairly rich in iron ore deposits, and some amount of iron ore is practically found in all parts of the country. India is the fourth largest iron ore producing country in the world. The first one is Australia, second Brazil, third China, fourth India, and fifth Russia. Iron content found in these ores in India varies between 49 to 63%. Now the major iron ore belts in India are Bellary, Chitradurga, Chikmagalur, Tumkur belt. The second one is Odisha Jharkhand belt. Then it is Durg, Bastar, Chandrapur belt. The important iron ore producing states in India are Karnataka, Odisha, Chhattisgarh, Goa and Jharkhand. Karnataka is the largest producer and accounts for nearly 1/4 of the total iron ore produced in the country. So we come to Bellary, Chitradurga, Chikmagalur, Tumkur belt. Here it is Kudremukh mines. Kudremukh mines is located in the western ghats of Karnataka. Kudremukh deposits are known to be one of the largest in the world. Kudremukh lies in Chikmagalur district. Then it is Bellary. In Bellary district, iron ore is found in Hospet and Sandur. Then it is Shimoga and Chitradurga districts. Coming to Odisha Jharkhand belt. In Odisha, high-grade hematite ore is found in Badampahar mines in Mayurbhanj district. Then it is Kendujar district. This is also known as Keonjhar district. Then it is Sambalpur and Sundargarh. In the state of Jharkhand, iron ore is found in Singhbhum district. In Singhbhum, it is mined in Goa and Naumondi. Then it is Palamau district. Now we come to Durg, Bastar and Chandrapur belt. This belt lies in Chhattisgarh and Maharashtra. Here, very high-grade hematite ore is found. In Chhattisgarh, it is found in Bailadila range of hills in the Bastar district of Chhattisgarh, and then it is found in Durg district. The range of hills comprise of 14 deposits of super high-grade hematite iron ore. It has the best physical properties needed for steel making. Iron ore from these mines is exported to Japan and South Korea via Vishakhapatnam port. Then comes Maharashtra Goa belt. Goa has vast deposits of iron ore. However, the iron ore is of inferior limonite and siderite variety. In Goa, the richer and larger varieties are confined to North Goa. In Maharashtra, it is Ratnagiri and Chandrapur districts. Then it is manganese. When it comes to manganese, India ranks somewhere 6th in the world. The leading countries are, first one, South Africa. Then it is Australia, China, Gabon, Brazil, and then it is India. Manganese is mainly used in the manufacture of steel. Nearly 10 kg of manganese is required to manufacture 1 ton of steel. 2/3 of the country's manganese reserves are found in peninsular India. It is found in the Nagpur and Bhandara belt of Maharashtra and Balaghat and Chindwara belt of Madhya Pradesh. Now in Odisha, it is found in Kendujar, Sundargarh, Mayurbhanj, Talcher and Koraput. In Karnataka, it is found in Shimoga, Bellary, Chitradurga and Tumkur. In Telangana, it is found in Adilabad, In Andhra Pradesh, it is found in Vijayanagaram, Vishakhapatnam. In Goa, it is found in Sangam. We now come to the next metal, that is bauxite. Aluminium is obtained from bauxite. Bauxite deposits are formed by the decomposition of a wide variety of rocks rich in aluminium silicates. India's bauxite deposits are mainly found in the Amarkantak Plateau, Michael Hills, and the plateau regions of Bilaspur. Odisha is the largest bauxite producing state in India. In Odisha, the districts are Kalahandi, Korapur, Bolangir, Sundargarh, and Sambalpur. In Jharkhand, it is Ranchi and Palamau. In Gujarat, it is Jamnagar, Junagadh, Kheda, and Kutch. In Maharashtra, it is Ratnagiri, Thane, Satara, Pune. In Madhya Pradesh and Chhattisgarh, it is Amarkantak Plateau, Michael Range, the Katni area of Jabalpur district, and the plateau regions of Bilaspur. Next metal, and that is copper. Now, India is critically deficient in the reserves and production of copper. Being malleable and ductile and a good conductor of electricity, copper is mainly used in electrical cables, electronics, and chemical industry. Now, it is found in the Balaghat mines in Madhya Pradesh, Singhbhum district of Jharkhand, and Khetri mines in Rajasthan. Coming to non-metallic minerals, the first one I would say is mica. Mica is a mineral made up of a series of plates or leaves. It splits easily into thin sheets. These sheets can be so thin that 1,000 can be laid into a mica sheet of a few centimeter high. Mica can be clear, black, green, red, yellow, or brown. Due to its excellent dielectric strength, low power loss factor, insulating properties, and resistance to high voltage, mica is one of the most indispensable minerals used in electric and electronic industries. Now, the important states where mica is found is Andhra Pradesh, Rajasthan, Bihar, and Jharkhand. Andhra Pradesh ranks first in the production. Mica belt lies in the Nellore district. It is found in the Gudur mica mines. And Gudur mica mines, when I say Gudur, it is a town in Nellore district. Then it is Vishakhapatnam, West Godavari, and Krishna. These are the other important mica producing districts. In Rajasthan, the mica belt extends from Jaipur to Udaipur along the Aravalli range. Mica deposits are found in the northern edge of the Chota Nagpur plateau. Then it is Bihar. In Bihar, it is mainly found in the Gaya district. Then it is Jharkhand. In Jharkhand, it is found in Hazaribagh and Koderama districts. Then we come to limestone. Limestone is mainly used as a flux in the iron and steel industry. Steel is made from mainly 4 ingredients, and they are: the role of limestone is it mixes up with the impurities, and the main impurity is silica and brings it out. That's why we say it is used as a flux. Second, limestone is used in the cement industry because cement is mainly made from limestone, gypsum, coal, and silica. In Telangana, it is found in Adilabad, Warangal. In Andhra Pradesh, it is found in Prakasham. In Jharkhand, it is found in Singhbhum, Palamau, Ranchi. In Gujarat, it is found in Dwarka, Porbandar, Sikka. In Chhattisgarh, it is Bilaspur and Durg. In Maharashtra, it is Chandrapur, Nanded. In Odisha, it is Sundargarh, Sambalpur, Kalahandi. In Rajasthan it is Savai, Madhopur, Dungarpur, Bikaner and Ajmer.